Hi, my name is Todd. We at Fagor Automation would like to congratulate and thank you for your recent purchase of the Fagor CNC package. We hope after this basic training video you'll quickly learn the ease and value of your purchase. I know some of you out there saying I can't do CNC, it's too complex, it's too hard. But I say no, you can. CNC programming is made easy with the Fagor 8040 CNC. If you can read, you can do CNC, and I'm going to show you just how easy it is today. The Fagor approach to conversational programming is based upon a unique icon key-based programming system, which is an extremely interactive method of utilizing a static graphical example and fill-in-the-blank data windows for each operation. To create an operation, all you have to do is fill in the blanks and, in short, press the cycle start key. In this video, you will also learn how to home your machine, set tool offsets, your part zeros, and simulate your program to graphics. But enough talk about it. Let's just jump right in and get started. The first thing I'd like to do is give you a quick explanation of our keyboard just so you have a good idea how to operate it. We start off with a fully alphanumeric keyboard. Our enter key is a bright yellow key, kind of gets your attention. You're going to use the up and down and arrow keys and the page up and page down keys for negotiating through our various cycles. You have a reset key, cycle start, cycle stop key, manual feed rate override knob. This is a percentage override of the feed rate that you have programmed. We have an execution key, a graphics key, a save to part program key or program recall, and our main menu key. We have icon keys, which are located on the F1 through F7 soft keys, as well as blue keys here. You'll notice they have a small picture on them. These small pictures are the icons representing the cycle that we're going to execute. I'll show you a little bit more about that a little later on. We also have them up here on the left-hand side. You can see such things as bolt hole pattern, linear grid cycle, that type of thing. We have spindle control, spindle forward, spindle stop, spindle reverse. Simply pressing these on the jog mode will turn them on and off. Spindle speed override. Each time we click this, we're going to go up 5% or down 5% for every click of the program spindle speed. And if you have the option for spindle orientation, this is our spindle orientation hotkey. This switch is our jog selectable switch. It's a three-tiered switch, meaning we have three different operations. Fully counterclockwise, you can see 100, 10, and 1. This is simply times the resolution for the hand wheel. Each pulse equals 1 times the resolution, or 10 or 100 times. Going over to the next mode, we can see we have jog, incremental jog, 10,000, 1,000, 110, 1. In other words, when it's at 1, each time I jog the axis, it'll increment by 1/10,000ths, or 1/100ths, and so forth. And fully clockwise is for just continuous jogging the axis. This block of keys is for jogging our machine around. Obviously X plus, when we press the X plus key, we're going to get X positive travel. X minus, X negative travel. Y minus travel, Y positive travel. And of course, Z minus travel, Z positive travel. We also have a rapid key right here. And what this means is whenever I have one of these keys to press and I press this rapid key simultaneously, the machine will move at the maximum programmable feed rate. So, for example, as you can see, with our rapid key, we rapid. I'd like to come back and do a little bit more, or look a little closer at our icon keys. Well, we have many, as you can see. You have a 0 home key, an ISO code where we can insert G code anywhere we want within our conversational programming, and we have various operation keys. For example, if I press this key with the drill on it, we're going to get a drilling cycle. We have a level key, which is very important. As you'll notice, we have 1, 2, 3, 4. What that means is we have 4 different types of drilling cycles we can program right now. By pressing the level key, we increment to each one, and we choose which one suits our needs for the given operation. This is the blue-white hotkey used for choosing various machining conditions within a cycle whenever you have a square box selection. This next key is the single block mode, pockets, bosses, profile pockets, facing, profiles, custom cycle call key, and finally a tool calibration key. Up on the upper left-hand side, we have a positioning key, rectangular hold positions key, grid pattern hold positions, bolt hole positions, linear positions, and random hole positions. I would like to have a little closer look at the icon keys. On the bottom, this bottom blue row, we have the home key, ISO G-code key, boring key, reaming key, tapping key, drilling key, and the level cycle key, the toggle key, of course, and the single block key. Just hit the key to see what you have. A special interest is the ISO icon key, which allows for inserting traditional G-code into your program at any time. On the left-hand side, we have additional icon keys with positioning on the bottom, rectangular, linear grid, bolt hole, linear hole positions, and random positions in the top left. Back down below the screen, the white keys also contain icon keys. For example, we have rectangular bosses, 2D profile pockets, and by hitting the level cycle key, we can see the 3D pockets as well. We also have bidirectional milling, or also called facing. Profile 1 icon key for generating point-to-point profiles utilizing multiple sets of XYZ positions. This cycle makes tedious linear positioning moves easy in a snap by bundling all the points within a single cycle. It really is an easy cycle to use. It's as simple as entering in up to 12 axis positions in series and then utilizing the graphical example. We simply enter in values such as the depth of cut and the safety plane, and the CNC does the rest for us. I also want to point out what the data in the dark blue highlight is at the top of each screen. It is simply showing us the current positions of the axis, the active feed rate, the spindle speed, and the tool. Another important key is the P-call key, which will allow us to open up any custom cycles or, for example, a conversational digitizing cycle. By simply highlighting on the cycle and pressing recall, it'll appear. This digitizing cycle really makes digitizing easy with a graphic example and the easy data entry into the windows. At this point, I just want to jump in and get our feet wet and actually program an operation, simulate the graphics, and then execute it. Thus, we're going to start out with a facing operation, and as you'll see, with icon key conversational programming, it will only take us a couple of quick minutes to program the operation and then execute it. The first thing we do is simply press the facing icon key. We then see we have two choices of facing cycles. To select, we simply press the level cycle key as previously mentioned. We can then choose between a standard facing cycle or a grooving cycle. Then, based upon the graphic representation, which shows the dimensions of the part that are being asked for in the data windows to the right, all we have to do is simply fill in the blanks, and that's it. We are face cutting a 10-inch by 5-inch part, and we're going to cut along the x-axis. So all we have to do is simply enter in the data. The starting point is x0 and then y0. The length of the part is 10 inches. The width is 5 inches. Thus, we're simply entering in data into the windows as shown per the graphical example. I am going to enter 0.200 inches for any overshooting, and considering our workpiece is well centered on the work holder, I think we'll just enter 0 degrees for any workpiece angle distortion, which I know we don't have with this work holder. For our safety clearance on the z-axis, I'll enter in a full ½ inch. That ought to be adequate for us for clearance of the part. Well, we know the top of the part is 0, and so we're just going to go ahead and enter that in. The depth of our cut will be just 1/100ths, so we'll enter in 1/100ths, press enter. We will then also take the full cut, the first pass, so we'll enter in the same number, 0.01. And our feed rate will enter the part be a very slow but safe 5 inches per minute. We'll go a little quicker during our cut at 10 inches per minute. 1200 RPM for our spindle speed seems reasonable. Another square box as we use the blue-white toggle key to determine our spindle direction. We'll go counterclockwise. Tool 1 with offset 1 will be our tools. So you simply hit tool 1, and then for the D, your offset 1. And because we're just doing a roughing pass, we went to 0 for finish pass, and leave these finishing pass windows alone here on the bottom. We've created our facing operation. Now we have two options. One, we can simulate it to graphics, or we could actually execute the program. I want to verify that our program data was good, so we're going to simply verify it to graphics. You do this simply by pressing the icon graphics key. Up pops our solid graphics. Then we simply press cycle start to simulate. Looks great, no visual problems whatsoever. I think we can go ahead and execute this cycle. I'll quickly clear the screen and escape back out of the graphic mode. For safety, I always take the manual feed rate override knob percentage down to 0. Then, to be able to execute the program, we simply hit the escape key from our cycle, and you'll notice we get the green cycle start key, simply indicating our cycle start key is now active. Upon pressing this, we're going to start executing the program. I'm just going to slowly feed it in using my manual feed rate override. Get it in there, make sure it's going to do what I think it's going to do. Looks good so far. I'll open it up. Now, I previously set my tool offset and my part 0 offset on this particular part, but don't worry, I'll show you how I did it a little bit later in the video. As you can see, it only takes a few minutes to first choose the operation you wish to perform, and then by simply pressing the appropriate icon keys, fill in the blanks, utilizing the graphic representation. Then we simply simulate the graphics by pressing the graphic key, and all was well. So we went ahead and executed this operation. It really is that easy. As we're finishing up the pass here, the machine will simply wrap it up to the safety clearance zone, and we'll be ready to go on and do our next stuff. If your machine manufacturer has equipped your machine with home switches, then I think everybody should know how to home their machine. It's fairly important. To home your machine, you simply press the axis key you wish to home. You'll notice that upon depressing that, the axis key highlights, or the axis itself highlights to the left. We then press the 0 home reference icon key. You'll see we are asked if we want to accept the home search request. Yes, I do. So I simply press the cycle start key and our axis begins the homing process. Now the machine locates the home position and then preloads the home value into the axis. Take note this value is not necessarily 0 and can be any number as defined by machine parameter. We then simply repeat the operation with the other axes. Start with the y-axis, press to home, and of course the z-axis. The same as always. You notice the Z may have a crazy number. That's just because the home position is in respect to where the true home position is. It doesn't mean it's any more inaccurate. It is an accurate number. In addition, we can also home all the axes at the same time. But instead of pressing the axis key, we simply press the 0 home reference icon key. And then accept by pressing the cycle start. You'll notice that it homes the axis in a preset order. Typically, most machines will home the Z-axis first to clear it before the X and Y axis. Please consult with your manufacturer to ensure this feature has been pre-programmed before executing. Now we're going to jump right in and start creating a multiple cycle program. However, the first thing we have to do is learn how to set our tools. To do this, we simply press our tool calibration icon key located at F1. Once in here, we decide the Z coordinate of the calibration part. In other words, the top of the part is Z0, enter. I like that number. But we actually want to change the tools. So we're going to Tool 1 was our big face cutter. Tool 2 is going to be an end mill we're going to use to cut a pocket and some profiling. So we simply key in Tool 2, press cycle start. The machine automatically locates to the tool change position. I've changed the tool physically to Tool 2 now. As you can see at the top of the screen, the CNC is telling me to change to Tool 2 and press cycle start. I already have, so I'll just simply press cycle start. And the tool is loaded. Next, the CNC asks us to touch off on the calibration part and press Z enter. Therefore, I'm going to touch off the Z axis on the top of the part, which is we've already previously entered in a value of 0 with this tool loaded. There are a variety of ways to touch off on the part, Some will actually use a piece of paper to slide under the tool or the part or a no-go gauge. However, considering we are just cutting machinable wax for this demonstration and to save time, I'm just going to get it close by my eyes. And it looks like we're fairly getting close right now. Now we simply press Z and then enter as the CNC told us to do. The next window is tool length wear offset, which we don't have any at this point. After that is the entry for the tool radius, which I know my cutter is 1/4 inch, and considering it is asking us for the radius, I will enter in 0.125 inches. And the last entry is a radius wear compensation offset, which is not relative at this time. It's as simple as that to set tools. The next operation we need to do is simply find our XY part 0. We know from the blueprint that it's located on the front left-hand corner of our part. So all we have to do is touch off at the part 0 position with each axis and then preset our home position. Because we have a 1/4 inch cutter, we are the radius of the tool from the part when we touched off on the part. And because our tool is on the negative side of the part, we simply enter in a negative 0.125 inches into the x-axis. It will ask us if we are sure. Yes, we are. So we're simply going to press enter. We then also touch off on the y-axis on the part and repeat the operation by simply entering negative 0.125 into the y-axis just as before. Press enter, and we're done, and now we have good 0 offsets. Now we're ready to begin creating a multiple cycle program. You might want to press the pause button to study the blueprint of the part we're getting ready to cut, at least for a couple minutes. But as you can see, we have a 1/2 inch deep pocket on the right hand side of the part with a series of linear drilling holes to the left of that, an 8-hole bolt hole pattern to the left of that, and a small profile at the bottom left and top left. The first operation we want to do is a pocket. Thus all we do is press the pocket icon key located at F7. And we have a simple pocket. Now you notice we have 4 different levels. We're going to choose which one using the level cycle key. Rectangular pocket, circular pocket 2. I'm just going to do not a simple pocket but an actual rectangular pocket right here. So we know right away we have to start with the center point or the corner. Center, corner, center. We're going to start with the center per the print. We know that our starting position is 7 inches from the print. On the y-axis, that's 2.5 inches from the print. We know the length of the pocket is 4 inches from the print. The width is 3 inches. And the angle. The workpiece is well squared on the work holder, so I'll enter 0. Next, using our blue-white hotkey, we can select between a chamfered pocket corner, a square corner, or round corner. Our part shows a round corner with a radius of 0.15 inches, so that's what we'll enter. Our z-axis safety distance will be a full 1/2 inch above the part. The top of the part is 0, as previously discussed, so we'll enter that. The depth of the pocket is a 1/2 inch, so we'll put 0.5 inches in there. How much we'll take off in each pass? We're going to take off 0.1 inches on each pass. Thus we'll have 5 total passes in creating our pocket. And our feed rate for entering the part will be a safe and very slow 5 inches per minute. So that's what I'll enter in for the feed rate. Our roughing feed rate will stay with a slow 10 inches per minute. 1200 RPM spindle speed seems reasonable. With our hotkey, again, we choose our spindle direction. We're going to use tool 2 and offset 2 for the pocket, which is an end mill. And 90 degrees sideways penetration angle is what we will use. It's pretty standard. And we're not going to be doing a finishing pass with this pocket, so we don't need to fill out anything else. we're good to go. Now, before entering into the program as done before, we want to simulate the cycle of graphics. And as before, we simply press the graphics key. And then press cycle start to actually execute the graphic. And it looks like it's doing exactly as we programmed, taking 5 levels down. It's taking 100 thousandths off each pass for a total of 5 passes. And this certainly looks like it's a good graphic, just as the blueprint shows. While we have the graphics up, I think it will be beneficial to quickly show you the various graphic views we can utilize and a few of the parameters associated with graphics. We can look at different types of graphics. We can look at just in 3D, XY plane, XZ plane, YZ plane, combined view, my personal favorite, the section view. Well, we can see from all angles simultaneously in a solid type format. And of course, solid graphics as we've been seeing. We can define our display area simply by hitting display area. We're defining our part here, the X minimum, the maximum value, the minimum, and the maximums, all right here. It's very simple. Convert metric to inch anytime we want. We can zoom in by pressing zoom. Then we can move our zoom around, and via our plus or minus key or these soft keys, we can zoom in or zoom out. We can also change our graphic point of view. Now our XYZ display can now be rotated to any position we desire using our up and down and left and right arrow keys. And then simply by pressing enter, rotate the part around. And we also have graphic parameters where we can set the simulation speed, the path colors, and the colors of solid. Now, I previously glossed over really quickly, but I want to go back over the display area definition of our part a little closer. Now, first thing I'm going to do is I'm going to clear the screen. I'm going to hit my F2 for display area. Up here you'll see the X minimum value, the maximum value, the Y minimum value, the Y max, and the Z minimum value and the Z max value. For example, let's say we wanted to change the X from 0 to 5. We simply press 5. I can press enter and you're going to see the graphic change to more of a cube. I go right back into display area. I can set the X max at, instead of 10, 7. More of an oblong. Whatever we set the display area to is what we're defining our solid graphic with. Now, one common confusing part for many customers is they look at the Z minimum and the Z max. The Z minimum is typically your depth of your part. The Z max is the face. That's why I have 0 and then I have Z minus 3. It's very common to reverse those. You want to make sure you get them both correct. Well, we know we have a good pocket now, so we want to save the operation to the program. To do this, we simply press the part program key. We want to create a new part, so we will simply not press the enter key, but instead we'll press the part program key again. That's a common mistake, incidentally. And as you'll see, a window will open up at the bottom asking us to enter in a part program number. 25 sounds like a good number. I'll enter that and press enter. It then asks us for the program comment or name. We'll call it the video program, and then we'll be pressing enter. Now next, after that, all we're going to simply do is hit the right arrow key to move the highlighter to the right of the screen, and then press enter to save the cycle to the program. It's that simple. We then press escape to back out, and we can now start programming our next operation. The next operation will be the profiles at the top left and bottom left of the blueprint, simply because we'll be utilizing the same end mill tool. Simply hit the profile icon key, and of course we have 2 cycles to choose from, so we'll hit the level cycle key and we'll pick which one. Ours will be number 2. First thing we have to do is enter in our starting points. It's pretty simple. Just look at the graphical display in your blueprint, enter in the data. We are now ready to create the actual geometry of the profile in our MIDI CAD/CAM system, or as we call it, the profile editor. To do this, we simply enter a profile number in the window labeled profile, in which I have already entered in the number 555, and then by simply pressing the recall key, we will automatically enter into the profile editor. Then we press edit, then we would choose the profile selection. The starting point for our blueprint for the lower left profile is X0 and Y0. Simply entering that on the screen, and then we press validate. And we get a position mark in the center of the screen. Our first move on the profile is a straight linear move. So I'll select straight line. Now we enter in the endpoints of our linear move. The X is 1.5 inches and the Y is 1 inches per the print. We then simply validate our move, as you can see on the screen. Our next move is a clockwise arc. We simply press F2 to activate that. It is now asking us for the arc endpoints. For the x-axis, it is 2.5 inches. The y-axis is 0 inches. And after we've entered these in, we'll go down below and we'll enter in the radius for the arc, which is 1 inch per the blueprint. And now we validate as the screen shows we have done. Now with the next key, we can look at multiple solutions. And of course this is the correct solution, and I would choose it. We would then press the Save and Continue key and escape back to the Finish key. And of course activate that. We're then asked to enter in the name for the profile. We'll call it Profile 1. Sounds like a good name for this one. Now this was our profile editor, which is a mini onboard CAD/CAM system that is really quite easy and quick to utilize, as you just saw. Within only a few seconds we were going. For our Z-axis safety distance, we'll use 200 thousandths. The top of the part is 0. Depth of the cut will be 0.125 inches. We'll do just one cut, so we'll enter 1.125 inches also for the depth of the pass. Entry feed rate will be a slow 20 inches per minute, seems fairly reasonable. The roughing feed rate will be an even slower 10 inches per minute. And I think we'll go with a relatively harmless spindle speed of 1200 RPM. Spindle forward is okay. Tool 2 offset 2 is okay. We have a square window, so we know we're going to use the blue-eye toggle key. We can choose left-hand compensation or right-hand compensation or without tool compensation, considering we're doing a center cut. We're now ready to simulate the graphics by pressing the graphics key and then pressing cycle start just as before. The graphics match the blueprint perfectly. It looks like we have a good operation. We will back out of graphics and press the part program key to save our operation to the program. Because our program is still open, thus all we have to do is press enter to insert the cycle. We're going to do a quick positioning move to clear the tool above the part. This isn't always necessary considering the cyclists retract us to the Z safety distance, but I wanted to show you how to make easy positioning moves, so we'll go ahead and do just one. We simply press the positioning icon key on the lower left-hand column. You'll notice we have two square windows. The first one determines if we do direct positioning or move the Z first or the XY axis first. The second one determines if we move to the program feed rate or at our maximum rapid speed. I have chosen direct positioning and the programmed feed rate. And the actual positions we are moving to. The X-axis is -1, the Y-axis is -1, and the Z-axis is 2. We don't have to enter any other data for this move, and we're ready to enter the clearance move into the program by, as before, simply pressing the part program key. And then pressing the enter key to simply insert into the program. Now we're ready to create the top left profile. Considering we've already done one profile, I'm going to start going through this a little bit quicker. So we once again press the profile icon key. And based upon our blueprint, the starting point is X0, Y5. We'll call it profile 556. And then, of course, we're going to press the recall key to enter back into our profile editor. Yes, we want to edit a profile. We will then enter in the starting points. And, of course, we're going to validate right after that. Now, our next move after that will be the straight line move from these 2 points. So we simply press the straight line, which is F1. We will then enter in our ending points. And then we're going to validate again. Now after this, we're going to be doing a counterclockwise arc this time. And so we're simply going to press the counterclockwise key. X2.5 and Y5 is our ending points of the arc. And the radius of our arc is 1 inch. And then, of course, after entering that in, we will validate once again. And once again, we have 2 choices. Hitting the next key will reveal both of them. But of course, the first choice matched our blueprint perfectly. We would choose it. We would then press Save and Return, and escape back to our Finish key. And this is where we're going to call this profile. The first one was Profile 1, so I guess we'll call this Profile 2. Make it easy for us to remember. And the control is smart enough to keep the values previously programmed in the first profile. So if we agree with the value, we can simply press Enter for each one. The values are the same. Profile 2 and Profile 1 are identical, except they're mirror imaged from each other on the blueprint. After this, we're simply going to go and simulate to graphics by, as always, simply pressing the graphics key. The graphic looks perfect. Now let's save it to the program by escaping out of graphics and then pressing the Part Program key again. And then we press Enter to insert the operation into the program. We're now ready to move on to the next operation. We're now ready to create our linear grid drilling cycle array. We start by simply pressing the drilling icon key. You notice we have 4 choices. Via the level cycle key, we'll choose one of them. You should choose based upon the data available from your blueprint. In our case, drilling cycle 3 works perfectly. We enter in our positions for the first hole. X-axis 3 inches, Y is 1 inch per our print. Our clearance position will be a full ½ inch above the part. The part is at position 0. We will retract a ¼ inch after each peck. And the total depth of the hole is going to be 0.3 inches per the blueprint. I'm getting ahead of myself just a little bit, but we're okay. And we'll peck in 100,000ths at a time. And we're going to dwell for 1 second to break the chip. And we'll use a super safe feed rate of 5 inches per minute again on the entry. 1200 RPM seems to work for us. The spindle forward is okay. We're going to be changing to tool 3 and offset 3 for our drilling operations. Now next we have to figure out where we're going to put all these holes. We simply press the grid pattern icon key. With the help of the graphic picture, it'll be a snap to enter in the hole locations. Simply because all the data is displayed right on the screen, we just have to fill in the blank. At the top of the control, automatically brought over our first hole location entered from the drilling cycle. We just have to press Enter to validate these positions. We see another square window. We'll toggle the blue-white toggle key to choose the best configuration for the blueprint data we have. In our case, it is configuration 3, considering we know the pattern length and the width and distance between the holes. It is now asked for the x-axis pattern length, which is 1 inch. The y-axis length is 3 inches. The distance between each hole on the x-axis is a ½ inch. The y-axis distance is also a ½ inch. We don't have a work holding angle to offset or compensate, so that'll be 0. But the angle between the 2 sides is 90 degrees, so we'll put 90 degrees in here, and just like that, we're done entering in the data. Now we simply simulate the graphics by pressing the graphics key once again. Upon pressing start, it informs us that a tool change we will have to make, which is fine. Looks great so far. All the hole positions seem to match our blueprint perfectly so far. We just have to give it a minute to catch up with us. It really is this simple, folks. Just fill in the blank, press the graphics key, press cycle start, and you're simulating a program to graphics and ready to execute it, quite frankly. Those holes are perfect, so now let's save it to the program. We do this simply pressing escape out of the graphics mode, and then of course we're going to press the part program key and then enter to insert the operation into our program. The next operation we're going to be doing is our final drilling operation, which is the bolt hole pattern. Once again, we just press the drilling icon key again and choose the appropriate cycle utilizing the level cycle key. In this case, we're just doing a simple drilling cycle, so we would choose the drilling 1 cycle. We then enter in the positions of the first hole. We'll stay with a 1/2 inch safety position above the part. The part is at 0, just as before. Total depth of the hole is 0.2 inches per the blueprint, and we're just going to make a single pass to depth, so our peck will also be equivalent to 0.2 inches. And we'll dwell for a second at the bottom of the hole to break the chip. We haven't killed anybody at 5 inches per minute feed rate, so we'll stick with that. Spindle speed at 1200 RPM has been safe. Spindle forward is good as well, and we're staying with tool 3 and offset 3. It's the same tool we used to drill the linear grid cycle pattern. Now, to create the bolt hole pattern, we simply press the bolt hole icon key. Using our level cycle key, we'll select the second pattern based upon our blueprint information. The first window is the x-axis arc coordinate center of 1.5 inches. The y-axis center coordinate is 2.5 inches. The arc radius is 1 inch. The angle between the starting point with respect to x-axis is 0. We have 8 holes total on our bolt hole cycle pattern. Therefore, we'll put 8 in there. The angle between each hole is 45 degrees. So we'll enter 45 into our parameter. The angle between the endpoint with respect to the x-axis is 45 degrees as well. And I also want to point out that in the bottom text window in all cycles, the information the control requires for the highlighted window is explained. Now let's simulate the graphics as usual by pressing the graphic key. You'll notice the control will always warn us of a tool change in the upper window. It's supposed to do that. And it's looking like we have a good graphic for our bolt hole pattern so far. Looks great. Let's save it to our program by once again pressing the part program key and then of course the enter key to insert. It's that simple. A bolt hole pattern can be done in literally 1 minute. And now we'll do a positioning move to clear the axes. Once again, we press the positioning key icon key. And we're simply going to put some clearance numbers. -1 for the x-axis, -1 for the y-axis, 2 inches for the z-axis. Do the trick. We'll get rid of our tools. And of course, we're now going to save the move to our part program by once again pressing the part program key and then the enter key to insert it. Now, I think we're ready to simulate our whole program in its entirety one more time to graphics before execution of the program. To do this, we simply, using the up arrow key, we're going to key it up to the very first operation. And then simply press the graphics key again, and then the cycle start key. And we can see the pocket being created. It looks great so far. 5 total Z passes to get to the final depth. And now our profiles. They look good. No problems. Change the tool, it's telling us. So what we'll have to do. Even in simulation, it'll tell you you're going to have to do it. Okay, our linear grid cycle is looking good so far. Graphics can obviously quickly and show you any programming errors you may have made. It will also generate appropriate error codes with explanations if you have any serious errors such as illogical geometry errors or travel limit errors. As shown previously, remember we can set the graphic simulation speed anytime we want. I have it going pretty fast right now, but you can certainly slow it down if desired. Okay, let's have a closer look. We've got our pocket, linear grid cycles, profiles, and our bolt hole pattern. And as you can see, it looks like it's a pretty darn good match for our blueprint. And I'm pretty certain we're ready to execute our program. So let's just jump right into it and give it a try. Well, I think we're ready to go. I simply hit the Part Program key to go back in and ensure we're highlighted on the first operation and ready to execute. Now to execute the program, all we have to do is press the Cycle Start key. I keep the manual feed rate override switch at 0% at the initial start, and then I just slowly let it go, start creeping on over. The first operation it's going to do is the pocket cycle. If we don't have any problems, I'm just going to let it go. The program seems to be right on the mark, executing right in the center of the pocket and working itself out. While a program is executing, you can see the blue-white toggle key or toggle the blue-white toggle key to change from the standard XY position screen to a dynamic execution screen with a program command, actual position, distance to go, following error, active code, cycle time, program commands, part program number, and the cycle and operation at the moment, and any messages up in the right-hand corner. To go back to the simple XYZ position screen, simply press the toggle key. Back and forth, it'll kick you. We can also hit the graphics key at any time. Pressing again takes you back out of graphics. We decided to cut wax for this video simply because we thought it'd be easier to see visually for the video. We might have been wrong, not sure, but the pocket does look great. And now we're jumping over to the first profile. It started right on cue. It's looking great so far. I really think anybody can do this stuff. Let's press the Cycle Start key and let her go. The other profile is now executing. It looks pretty good as well. And it appears the linear grid cycle holes hit the mark as well. Now we're on to the bolt hole pattern. They look good. We have a finished part. And it took us just 5 or 10 minutes to program, simulate, and execute. This video is about icon key conversational programming, but our controls with 8040MC or 8055MC are equipped with a very, very powerful G-code system that I'd like to spend just a few minutes with you getting you familiar with it. To access the G-code system, we simply press Shift and then the Escape key. The second page of the main menu contains various modes typically for the service engineer, such as diagnostics, with a control configuration, hardware test, and adjustments. Most customers rarely enter this mode. A mode a little more commonly used is the machine parameter mode, which contains the majority of machine default conditions for your axis, spindle, serial parts, and PLC. Parameters contain a variety of information, such as your software travel limits, maximum feed rates, and much, much more. Modifying them is as simple as clicking on the appropriate soft key below. Back on the main page, we have the utility mode, which contains a directory of all stored programs with their name, the size, the date, and the level of security listed. We can copy, delete, rename, or protect the programs from this mode. And of course, we can navigate through the mode with the up and down arrow keys. The next mode is the tables mode, which contains the tables for zero offsets, tool offsets, tools, and parametric parameters. To modify our view is simple as pressing the appropriate table. Once in the table, we can convert to metric or inch. We can save, load, delete, find, modify, or edit any variable we wish to. Here we can also see the tool offsets table and the current loaded radius, the length, the wear compensation. We can also convert to metric or inch at any time, save, load, delete, find, modify, or edit the variables at any time that we desire. Our next mode of operation is the jog mode. So we pressing F4, we enter into it. Within the jog mode, we can do a reference home search, preset and axis position, a tool offset mode, MDI mode, a custom user mode, display selection, and of course we also have metric inch conversion. Our next mode is the edit mode, where we create programs or modify a program. Once in the edit mode, we can also edit, modify, find, replace, delete, or move program segments. To create a G-code program, we simply select Edit and then CNC Language, and we're ready to program with traditional G-codes. There is also a high-level language that allows for quick and easy program conditional statements or jumps at any time. All we have to do is hit the high level and select what we want to do. And with the conversational keys at the bottom, press enter. We also have a teach-in editor, interactive editor, and access to the profile editor. Within the interactive editor, it simply makes G-code easy with conversational type programming. For example, if we chose probing, we then have a library of probing and digitizing cycles to choose from. To use the editor, simply choose an operation such as digitizing cycles and select the operation. And once the graphic pops up, all you're going to do is fill in the blank programming type format. All machining operations are accessible and made easy with the interactive editor. Another feature I'd like to show you how to use is the help key. Within the G-code editor, you can type in your G-code command, and then by simply pressing the help key, a graphical example will be called that allows for easy fill-in-the-blank programming, just as in the interactive editor. The help key is located right below the bright yellow enter key. I'd also like to show you a conversational engraving CAN cycle we have that allows for quick and easy programming through fill-in-the-blank windows, as you can see. The next mode is the simulation mode, in which we can access local memory, card A, or via the serial port DNC. The directory shows the program number, comment, and size as previous modes. We also have the ability to navigate through the up and down arrow keys to choose our program. And once we have chosen our program, we can simulate our programs, the theoretical path, or just the main plane, or various other selections. The last mode of operation is the execution mode, which is similar to the simulation mode. However, we're actually executing the program in this mode. We can see in this mode the command, actual position, distance to go windows, active codes, parts counter and clock. We even have a tool inspection mode, single block mode, and several different screen display options to choose from. I'd like to give you just a quick glimpse of a few of the features of our offline DNC software program. For uploading and downloading files to and from the CNC, we click on Files from the main menu. The directory in the right-hand column shows the programs resident within the CNC. In the left-hand column, we have files located in the PC. In the center, we have various icon keys we can use for uploading and downloading. With these keys in the middle, we can upload or download just a single program, or using the package icon keys, we can download all programs within the directory. Simply by pressing on the key, everything highlights. Or utilizing the keys below the package icon keys, simply upload and download programs one at a time. To upload or download, it's as simple as highlighting the program and clicking on the appropriate icon key. In this case, we were uploading from the CNC to the PC. The process is complete. Now the program is copied to the PC directory. It was that quick and that easy to use DNC software for uploading and downloading. Another nice feature of DNC is the infinite length execution mode, also commonly called drip feeding. In this mode, we can select a program to drip feed to the CNC control. We can determine the number of repetitions, the block on which it begins execution from, and the mode it is executed at the CNC right here from the PC. We can also monitor the status of the executing program right here from the screen. This is a popular feature with a lot of customers. Another neat mode worth a look at is the remote keyboard control DNC feature. Right here from your desk, you can execute keystrokes to the CNC. In effect, you have the ability to take control of the CNC keyboard from your PC. A lot of our customers love this feature for a variety of reasons. Another customer favorite, and perhaps their most favorite, is a feature called telediagnostics. As our customers call it, instant service. Through cyberspace, our technicians can access your CNC and provide instant service support to you. We can see what you see to help you diagnose any CNC problems or just provide simple programming support to you all within just a few seconds utilizing instant service. If we were having trouble programming this drilling cycle, our technicians would see exactly what you see on the screen and in real time. Please contact the Fagor service department for more information on this feature. Another interesting and useful feature of DNC software is the ability to convert DXF files to G-code. It only takes a few seconds to do and is accomplished by simply clicking on the program and it automatically converts. And for the customers who have earlier generation 8020 or 8025 series Fagor controls, we also have an automatic program format conversion to 8040 or 8055 format, also accomplished with just a click or two within the DNC software program. This wonderful DNC software program is available as a free of charge download from the Fagor International website at www.fagorautomation.com. Well, that concludes our 8040 MC training video. I thank you for taking the time to watch this training video. We certainly hope it helps you to reach the productivity level you desire. I'd also like to point out the error solving manual and the examples manual. These two manuals will prove to be a wonderful resource to you during your learning process. If you ever need further assistance, please do not hesitate to contact the Fagor Automation Service Department at our toll-free number 800-423-2467. Thank you from the entire staff of Fagor Automation.